All right, good morning, everyone. Welcome to this week's virtual breakfast series. This morning, I'll be your host. My name is Steve Whittington, and we have a great topic today for everyone. I'm pleased to host this morning's virtual breakfast with Dr. Marty Chilvers, who's an associate professor at Michigan State University, and today he's going to be discussing tar spot management.
All right, let's get into this then. So please put your questions in the chat there with respect to tar spot. That can be really helpful in terms of getting to what we really need to talk about. Before I get going, I do want to thank some of the sponsors, some of the research work, particularly the Corn Marketing Program of Michigan. Without the support, we wouldn't be able to do a lot of the work that we conduct, so thank you. So just really quick, this is what we're going to see at this time of the season when we're out there looking for a tar spot. Again, and you've been told this again and again, and I think you know it now, but like one of the things that we often do see confused with tar spot is bug poop. So make sure you put some spit on that leaf and see if that, or some water, and see if that that bug poop will rub off. If it doesn't rub off, if it's embedded in the leaf tissue, and there's actually like a very small but black structure inside of that lesion, then this could very well be tar spot. We also turn that leaf over and it will be on the other side of the underside of that leaf as well. But what we're looking for are those little lesions that are sort of black, a little bit raised in appearance. And by all means, take a high quality photo and send that to me and I can help you identify that. And also that'll help with some of the mapping efforts that we do every year, just to give you a sense of where it's at every season. So where does tar spot come from every season? It comes from our very own fields here in Michigan. Unfortunately, this is a residue-borne disease, so it hangs out on corn residue, and that's how we'll get those first infections of the season. And then once it's up in that corn, every one of these little black tar spots can produce hundreds of thousands of spores, and then it can just start to reproduce. So one of the really important things here as well is that it takes around about 2 to 3 weeks from a spore landing on the plant for us to actually start seeing it, it forming that lesion, and then about 3 weeks for it to really start releasing new spores. So this is really important when we go to try and predict with models where tar spot is going to be, and scouting efforts and future risk as well. So very, very early in the season, there really isn't enough corn leaf material out there to get infection up and rolling. And some of the conditions might not be met either. Maybe it's too cold as well. So, but once we have, canopy starting to really develop around, mid-June, depending on the field, that's a good time to start, just starting to pay attention. We've found it's as early as sort of late June in the country, and 1st of July was the first we sort of found it here in Michigan. So that's what we're looking for, 2 to 3 weeks between cycles, and it's coming from the corn in the fields. The other thing to really keep note of here is that it can come from neighboring fields. So we'll get to that in the final sort of recommendations, but crop rotation doesn't really seem to matter. You should be rotating for other, insect disease issues, but crop rotation really doesn't seem to matter too much with this particular disease. This is what we have so far. So just last night, actually, I was texted some images of tar spot in Monroe County. Completely not surprised, given that we've had, rainfall events at least the past 3 weeks now, if not a little bit longer. But it's important to have those leaf moisture events. And Phil this morning, as we were chatting, said they had somewhere between, 6 and 9 inches or something ridiculous. The really heavy rain, the total amount doesn't matter. The leaf wetness events is what matters. And the other thing I'm certainly thinking of now that we actually have some moisture in the soil, is the dew formation on the plants. That's another great way for this pathogen to start reproducing. Doesn't necessarily need a rainfall, it needs dew event. Of course, if you're irrigating, you're at higher risk as well, because you're creating more leaf wetness events. So We have we track this tar spot as it comes in, and you can see here on the maps that we've had detections in Iowa, some of them early, the 23rd of June. So I expect some of those areas, if they continue to receive moisture, to have some, potentially pretty significant losses, just because they had early detections. But we'll keep doing this. I mean, all these grayed out cells basically show you that tar spot is present in pretty much most of our corn growing counties across Michigan, even in the Upper Peninsula there. Some of the other work we are doing, we have a series of traps that are spore traps that are out there this season, just to try and see if we can do some early detection of tar spot. Scouting is still really critical and may end up being the preferred method, but we wanted to see if we could supplement that data. So we have these things out there collecting spores. So they're out there just pulling in air. We will then use some DNA techniques in the lab to see if we can detect that spore trap, prior to symptoms or at the very early sort of onset of disease. So we've got traps, sort of 5 traps around the state of Michigan here. And thank you very much to those people that are participating in that effort. And we also have some work where we're comparing different trap types. So we've got 5 different traps here that we're trying out. And then student Jill Check is doing a lot of work with environmental parameters to see if we can get a better understanding of when spores are being released and some of the environmental factors that are driving disease development. And again, environment is such a strong driver of disease. This slide just demonstrates how under irrigation, those extra moisture events can be enough to really drive disease. So I just wanted to put that up there as a reminder, and it's a great visual just to get that in your head that the environment really matters, and the environment between now and September is going to be critical in terms of the frequency of leaf wetness events that we get in terms of driving disease. So we were certainly hit yet again with tar spot in 2021. Our first main outbreak came in 2018, and 2018 was also a wet summer. We had lots of rainfall events throughout the summer, but tar spot at that point in time was really up the west, somewhat in the central of Michigan. It was not on the eastern side of Michigan. So we didn't have really any losses to tar spot out the east side of the state. Now that tar spot, since about 2020, is covering the entire state, it really just, we're just waiting for those wet years for it to develop. So in 21, we had some very significant losses in a lot of parts of the state again, including southeast Michigan, with reports, especially under irrigation, up to 100 bushels. Very similar to the reports we received in 2018, up to 100 bushel under irrigation. 50 bushels pretty common yield loss when it's bad. And even that sort of 50 bushel difference where we had sprayed at the right time versus where we had not sprayed a fungicide. 22, of course, was much drier. So tar spot was so much later to get started. In fact, it was so late, we didn't need to spray for tar spot. On the whole, I think we can say that for Michigan in 2022. What are we doing then in terms of risk prediction? So there is an app out there at the moment. So this is built on the last 5 or so years now of tar spot data. And this year, again, will be another learning year for us with this tar spot model. And this is from my colleagues in Wisconsin that are developing this. We send them a lot of data and help out in that way. But, they'll be able to feed this year into the model to help improve for those years where we have a very, very dry start and then start to get rainfall to improve predictions. But this is what it's showing. So July 12th, we showed risk above threshold. And basically these numbers are percentage risk values, I guess. So 0 to 100, and our action threshold is 35. So below 35, it's yellow, so lower risk. Above 35, it's red and high risk. And so July 12th, it was showing high risk for a tar spot. So what this really means is the conditions according to the model, are conducive for tar spot development. So it's meeting the leaf moisture parameters and some of the temperature parameters that the modeling work is finding. We look at it July 19th, that started to drop off in some areas of the state, which is interesting. That may pick up again if we've once some of those leaf wetness events get captured, and if we have more leaf wetness events pop in through the season. So I'd encourage you just to play with this model, use it as a tool, particularly, use it to maybe concentrate your scouting efforts. Here's what we've seen down at our Decatur location, where we do a lot of variety screening and fungicide work. So we've done our trials down there now over the last 2 years. We're into our 4th year of trials at that particular location. It had tar spot develop in 2019, so we put our trials in then. So we saw around, depending on the year and the trial, somewhere between 30 to 50 bushel impact when we detected tar spot in July, 7th to 17th of July. This is under irrigation, but previously the grower was just putting an inch on once per week. So, some additional risk, but not substantial. When we detected last year, August 12th, it was really just too late. We saw a very, very minimal impact. In fact, there was not enough tar spot to even really rate for disease. The amount was really low. There have been some instances. Jason Roth had a trial near Niles, Michigan in 2019, and they actually sprayed, I think it was about the 18th of August, and they saw a 20 bushel protection. That's because tar spot had moved in after their VTR1 application and was really starting to peak in that year. And him and I got really excited about that. We went around and did a whole bunch of late season spray trials the next couple of years and just didn't see any consistent response from that because the disease was not kicking up in those couple of years. So just keep this in mind. The earlier tar spot develops, typically, that may certainly result in greater yield loss. But again, it depends on the environment. And if the environment doesn't continue to promote infection, then the amount of loss is going to be less. One of the most important things you can do is speak to your seed dealer about the hybrids you are growing. Knowing susceptibility is absolutely critical, and certainly talking to your seed dealer, making sure you're using hybrids that have a reasonable resistance package is really critical. This is just a nice photo to demonstrate, hybrid resistance differences. Here's some data from 2021, and essentially what this does is it slows down disease. No hybrids are completely immune to tar spot. Every hybrid will get some level of tar spot. But what you can see here, the susceptible hybrid in red develops tar spot earlier in the season than the hybrid that is resistant to tar spot. And that is critical. Slowing down disease development is critical for trying to protect yields. We do a lot of fungicide trials, so let's just jump into those. This is a summary. This is multiple state trials. This is Indiana, Wisconsin, Illinois, and Ontario, and Michigan. So we've done a lot of trials comparing a lot of the competitor products there to see how they perform. Essentially, we see that all fungicides do a pretty reasonable job at suppressing tar spot. There are some products that seem to do a little bit better job than others. So this is the amount of tar spot we're looking at here, with some of the products doing a better job than others. When we look at the yield data, that's reflected again there as well. So this data that I'm talking about here is also available at the Crop Protection Network, and Steve will put a link up to this. So what we've done is started to rank these different products as to how they sort of perform for tar spot suppression, being good or very good in their performance. So we're starting to break things out now. We've got a couple more years of data and can see some differences between some of those products. So check out that Crop Protection Network publication. We'll update that every season so as we get additional data. The other big question we get is timing. And of course, this is always a challenging question because it depends when disease starts and the following disease conditions. But pretty much what we have seen, so myself as well as colleagues in other states, that a single well-timed fungicide application is often as good as 2 fungicide applications. So what is typically in a most typical year, what is a good fungicide timing applications? Well, very often that's going to be from tassel or silking timing through to about the R3, maybe we could argue the R4 growth stage. So that's what this data is demonstrating. Even with 2 applications here at V13 and R3, we had essentially 239 bushel harvested from a single application at R2 growth stage, which was the 5th of August for us. We yielded 238 bushels. So, a bushel less, single application at R2 in that particular instance. So that's what I'm just trying to demonstrate here. And the other thing I'll point out, and I think this is very consistent across trials, is that those early vegetative applications do pretty much nothing for tar spot suppression. So V6, through V10-ish applications are not going to do anything because it's too early. Tar spot is not there yet. Those fungicide products are going to wear off and you're not going to get the control that you need. Please also leave a check strip. It does not need to be the entire length of the field. Ideally, something that you can capture with a combine, of course. I think it's really critical that you learn every season. Just know what your numbers are. If you're spending tens of thousands of dollars in fungicide, I would want to know what my return on that investment is. I think that's really, really critical. And just a quick note, we are doing other work such as tar spot in corn silage. Of course, we had very, very little tar spot last year, but we ran these trials of fungicide efficacy, hybrid tolerance, chop timing to look at that for our dairy producers. So I'm hopeful we'll collect some more valuable data this year as well. And here's my final slide. So this is the risk factors and management things you should be thinking about. Hybrid resistance is going to be number 1. The weather, leaf moisture is going to drive disease. And that's a good segue to Jeff here in a second. Scout for well-timed fungicide applications, typically from VT R1 through to about R4. Leave those check strips. Scout for lodging potential too. Make sure you harvest those lodging potential fields first. And then don't forget about other diseases. I was out on Monday this week locally, and there's grey leaf spot out there is pretty much the only disease we're seeing, but it's out there. So don't forget about those other diseases. Crop rotation and residue management do very, very little to manage this disease. Okay, that's it. And please put those questions in.
Wonderful. Thank you, Marty. And then I think we're going to roll into some questions, Marty. Let me try to find the top. Even though Marty did answer some of them in the chat, we're going to go through them and sort of vocalize them to make sure all participants have the opportunity to hear those questions being answered. Phil asks, is that Tar Spotter app available, Marty, for everybody?
Yep. Yes, it's freely available. Just go to your smartphone app store and just search Tar Spotter. So that should be free to download and use. Excellent.
Christina asks, how far north in Michigan is Tar Spot?
So we do have a report in the UP, one of those counties bordering Wisconsin. I would put money down that I could find it in, if we get a heavy tar spot year, in any other county in the UP, basically, that had corn growing, I think we could find it. So pretty much everywhere.
Wonderful. Robert asks, is the yield loss due to lodging, or does tar spot impact grain fill or test weight, or both?
All of the above. So I know there was reports in 2019, we had great corn fill. Everything was looking good in some parts, but we just had lodging. So it depends on when tar spot comes in. If it comes in later, it may have more an effect on lodging. We may have okay grain fill, but I've seen other fields that have been absolutely decimated in terms of kernel depth. And one of the really interesting things to me, we had 2 fields side by side, both under irrigation, one receiving 1 inch a week, the other receiving 1/2 inch twice a week. And that field receiving 1/2 inch twice a week the kernel depth was half that of the 1 inch a week, and we just had so much tar spot because of those 2 applications of irrigation a week. That the kernels were so small they were just falling off the cob. It was incredible. So yeah.
I missed a question from Clyde. Is tar spot specific to only corn, Marty?
Yeah, as far as we know, we find the pathogen it causes is called Phylochora matus. We find other Phylochora species on grasses. There's a Phylochora graminis that infects other grass species. But yes, I mean, it looks to be very specific. We're still testing, so if we find tar spot on grass species, we will test that just to check, is this, the pathogen that causes tar spot of corn or not. But at the moment, it looks very specific. I did have some farmer tell me that he'd seen it on his sorghum Sudan grass. So I've just been waiting for an epidemic year to go back and look at that and just double check. But I think it's different species on that sorghum Sudan grass.
Interesting. Julius asks, any fungicide resistance observed in the fields thus far?
Yeah, and I really should have talked about this one. So if you are going to use a fungicide, please use a fungicide with multiple modes of action within the jug. We are very concerned with fungicide resistance in this pathogen. We see no evidence of that yet. We haven't had any field failures. Unfortunately, it's very hard because it's an obligate. It needs to grow on green corn plants. And surprisingly, this has been really hard to work with in the greenhouse. It causes all this devastation in the field. But only recently there was something published in terms of a method to cultivate it in the greenhouse on corn plants. What this means is that it's very hard for us to do fungicide sensitivity assays. But that's something we're going to be working on to get a sense of where we are in terms of fungicide resistance. But at the moment, fungicides are working, so that's a good thing. But we're very concerned about that.
That's interesting, Marty. So it's hard to sort of study the effect of fungicide in a controlled environment, like say a greenhouse. Do you have any theory or reason why that might be the case?
It appears to be It appears that we need those wet-dry cycles. So when we had tried to grow it in the greenhouse, we were able to get it, but not consistently. And some of the misting that we had done had probably just been too long. The misting periods had probably been too long, too wet for too long. The paper that came out from Bayer, and one of my former students was on that paper, so I was quite proud of that. But they had done like a wet-dry type, more of a wet-dry type system. And had better control of their temperatures. So sort of moderate temperatures are important, and we don't have ideal temperature control at the moment in the greenhouse.
Interesting. Thank you. John's comment here is just saying that tar spot reminds him of apple scab, and depending on what the conditions are, timing in that particular disease is everything as well. So sort of relating that to the tar spot and corn. Are there any other similarities that maybe you could comment on, Martin, between those two crop diseases?
Yeah, I mean, absolutely. Just like apple scab, apple scab comes from those bodies, those apothecial sort of, or ascospore, sorry, not apothecial, but anyway, spore bodies that overwinter and release their spores. So this happens with tar spot. Initially, and then it's very environmentally dependent, right? The moisture has to be there for plant infection, and then continued development and spread of the disease. It's very similar to quite a few different diseases that we work on. Yeah.
Okay. And I see there's just some information on here on the Tar Spotter app. So it sounds like it's available on the App Store. If you are used to downloading apps on your phone, just search Tar Spotter, and I think that you'll be able to find it pretty easily. Let's see here. Just to highlight, Marty, you said gave you contact information. So if you've got images of tar spot, or maybe you found that scouting in your own fields, his contact information is in the chat there. Anthony asks, I think his question is, would tillage help tar spot at all? Maybe mitigate diseases?
This is a great question, Anthony. I have had some farmers tell me they see worse tar spot after wheat. So I think if you are, and we've had some fields that have been really had very bad tar spot one year. They planted corn back into that the next year and pretty much no tar spot. One of the potential things that might be going on is some sort of natural biological control. We know that the tar spot pathogen is followed pretty quickly by a species that's basically in there parasitizing those tar spot structures. So maybe that's partly what's going on the corn fields. You have some of those microparasites in there, maybe helping to control some of the tar spot. It's obviously very heavily dependent on the weather though, right? We've had fields that have pretty much never been in corn before, planted to corn, and they have been absolutely decimated with tar spot. So unfortunately, the spores can move in from outside. And so that's why we see, fields that haven't had corn in them before end up developing heavy tar spot. If you were corn on corn, there may be some value in trying to manage the residue. But I think that's something we're looking at as well. We have research plots out here, but at the moment, we don't see a really strong effect of that at the moment. I was chatting with some industry colleagues the other day, and they actually had a little bit of evidence for a rotational effect, tar spot being worse after soybean than corn on corn. So the question still remains, but what I'm basically saying is crop rotation doesn't seem to matter that much for tar spot as far as we can tell. If you have a lot of residue, maybe some form of residue management might help a little bit, but it's not going to completely mitigate risk. I've had some farmers tell me, well, I'm just going to go out and moldboard plow. I'm thinking, well, that's just crazy. You're wasting all this diesel fuel, and there's no guarantee that you're going to eliminate tar spot. So I would not go that route.
Marty, with that tillage, is there a possibility that through the residues you could transfer a field that might be infected with tar spot to a field that's not currently infected with tar spot through that tillage?
Yep. Yeah, that's possible, Steve. But at this point in time, the whole of Michigan has inoculum available. So we're not so worried about that. You should be worried about that for soybean cyst nematode, introducing variants of soybean cyst or whatever it is, right? We don't want to be moving things around debris or soil. But at the moment, there's so much tar spot across the state. And when I show these maps as well, when we look at it over seasons, we can tell that those spores are moving for tens of miles. So they're not restricted to the immediate vicinity. If it was a soil-borne only disease like white mold, yeah, that's more of a case where you don't want to be moving sclerotia from one field to the other.
Okay.
Marty, in association with the distance that these spores move, and really a lot of guys are asking me, should I or should I not spray? I think it goes back to some of the things that you had on your website there.
Yeah.
If they go over the threshold, should they absolutely spray? Or if you go up and down, what effect does that have as far as spraying or not spraying?
Yeah, thanks, Phil. I didn't get back to your question. That's a really good question. So essentially, we were showing risk, like on July 12th, I was showing risk, and I pulled it out last night. And in some areas of the state, we're below the risk threshold. So really what that means is if you're above risk, I would get out there and scout. If I see no tar spot, personally, I would hold off that fungicide application. How late should you hold off? Maybe around about the R3 growth stage would be the latest I would potentially go. There can be some very few occasions where a later fungicide application could absolutely be beneficial, but those are going to be the rarer exceptions. And then knowing that you're actually going to, develop more tar spot later, is quite the trick to try and predict. But I would definitely tie it to scouting. You've got to know what disease is there. Even though we've had risk conditions just lately, do you actually have the pathogen present? Because that's critical.
Yeah, great question. Mike asks, are fungicide applications effective in reducing lodging?
Yes, they are. And I have some nice slides to demonstrate that. I won't bring them up right now, but basically, yes. Fungicides can assist. And we should also talk about setting expectations. The fungicide application will absolutely not eliminate all tar spot. Like that's not how these things work. It'll suppress tar spot and it'll give you like protection. I did the air quotes there for 2 to 3 weeks, right? And we definitely see that. We see a suppression of disease. And then, after 2 to 3 weeks, we will see tar spots starting to increase again in that field across all fungicides that we've looked at. What was the second part of that question, Steve?
That was it. Just does it reduce lodging in the plants?
Yeah, it does. But yeah, again, with the expectations, it doesn't completely eliminate the lodging potential, but certainly can assist with standability. Yep.
Norman's making an interesting comment. I found what he believes to be tar spot on cannabis 2 years back, which was outdoor grown. So have you heard of anything like that occurring in cannabis plants?
I haven't. So in terms of tar spot, if it was going to infect something else, I would think another grass species, not, a broadleaf plant. So I really doubt that it was the same species. I can't remember now whether we can accept cannabis samples in the lab, in the diagnostic lab. I know for a while there we couldn't. Maybe we still can't because of the federal. But we can look at hemp. So it'd be worth getting a sample into the diagnostic clinic if it happened to be hemp. But I doubt it.
Sounds like there's a good chance that it might be maybe a cannabis specific type of disease for those leaves versus a tar spot, even though there are similarities.
Yep.
James asks, is there an organic production control product for the tar spot?
We are looking, James, we are looking at biologicals. And like I said, there's a mycoparasite, so another fungus that actually feeds on the tar spot fungus. So we're trying to look at those, trying to set up some trials this year. I haven't seen any of those marketed for tar spot yet, but we have been looking at things, a whole range of different biological products. We just haven't really seen any efficacy yet. I will try and dig up some additional information after this meeting in case there's something that really pops out. But basically, we haven't seen any really strong efficacy from those products yet.
Yeah, and I'm wondering if there's maybe limited amount of different seed hybrids that a producer can choose for organic production that might mitigate the effects of a tar spot infection. So that might be sort of a disadvantage in organics.
Yes.
I don't know if you have any other comments about that, Marty.
No, that's it. You hit the nail on the head there, Steve. Okay. And I think, our sweet corn industry is also probably struggling a little bit here. They probably don't have the resources that go into the genetics that the big, grain companies have. Right. So that's another area where we're going to struggle a little bit, just trying to identify those hybrids with resistance and then the breeding for resistance.
Yeah. Eric asks, are there leaf wetness sensors at all at the MSU EnviroWeather stations?
And I could start this one. Yes, they're on most of them. They should have 2, but there's one reference, and at every site there's one sensor, and it faces north about a little over 3 feet above the ground, and it's at an incline. But a couple of caveats, and Marty may want to chime in. Leaf wetness is a very, very complicated variable. And of course, we look at that reference spot. And so inside any given plant canopy, and this would certainly apply to corn, there can be presence of water all over. It can be different. One other approach that's used to do this in the real world, and more so, I think, and including maybe the app that Marty showed, is looking at relative humidity and the number of hours above some threshold. And what we have found over time with EnviroWeather, and this has been replicated in other places, around 90% relative humidity. And actually the number, depending on the location, I've seen 88, but 90% relative humidity, if you count the number of hours, that's very, very, very strongly correlated with what that leaf wetness sensor sees. So if you don't have the grid, the leaf wetness grid, that's a really good other alternate strategy. And and Marty, some of the pathologists think it may even be better for a number of reasons, but I'll leave it at that. But we do have, if you look on the EnviroWeather site, you will see leaf wetness listed as one of the variables you can look at.
Excellent. Yeah, that is such a great website to the MSU EnviroWeather. You can pull a lot of different data and get a lot of different things from that website. And those spore samplers are a good example of our way of trying to be more proactive with different problems that we might be experiencing in the field in terms of diseases. Phil asked, is Canada getting some rain to put out some of the wildfires? Jeff, what do you think about that?
Well, they are, and wrote a reply, but it's not enough. And the geographical scale of what's happening in Canada is just beyond anything that's really been observed before. So there are some areas that have done a little bit better, but at last count that I witnessed, at least 600 fires still burning, and many of them are uncontrolled. They're in areas that they're not accessible. So some of the experts that look at the fire weather and so forth think it may be until the fall, until a change of seasons, cooler temperatures, that there's any major change. So again, this problem it's something that hasn't been observed before.
Yeah,
but it's happening this year.
Wow. Good question. Mike asks, growers have harvested corn before they harvested soybean to reduce the risks of lodging. This can cause harvest delays and potential yield losses in soybeans. Another reason to manage the tar spot. Marty, any comments about that statement?
I totally did not. The growers have managed harvest the corn before they've harvested soybeans to reduce. Oh, right. So just changing up the timing. Yeah.
Okay.
Right. Yeah. I mean, yeah, good point. Yeah. We're managing a system here, right? So
yeah,
got to think about everything, not just the corn. Yeah.
I think it's good to highlight, maybe thinking outside the box and trying to do different things to mitigate whatever disease is going on in your fields. Timing in farming and agriculture is a big thing that you can look at. So I think it's a pretty good comment.
Yeah.
Clay, go ahead, Marty.
No. Well, I was just going to throw in there too, just with respect to the weather. Yeah, absolutely, Jeff. For a lot of those models, we're using relative humidity because we can get all those issues you talked about, but we can use IBM weather that's sort of smoothed out using Morn stations, no doubt, smoothed out across the state and country.
Clay's asking an interesting question here too. I'm interested to hear the answer. How does tar spot overwinter, and are there any microorganisms in the soil, for example, like in a no-till system, that may reduce survival or may increase survivability of the disease?
Yeah, Clay, I would think that maybe under no-till situations, you get more of those mycoparasites that can infect the tar spot pathogen. And maybe that's why we sometimes see worse. There's not a lot of data on this, but there's 1 or 2 points out there showing worse tar spot under soybean corn rotation than continuous corn. So that might be one of the reasons. It's not guaranteeing you that you're not going to get tar spot under continuous corn no-till either, but yes. And some of those they're not dependent on being on the soil. They will be infecting the plants, not the plants, but infecting the tar spot lesions on the plant. But there will be other microbes in the soil there as well. They'll parasitize and feed on those tar spot bodies.
Interesting. Yeah, because I know in some diseases that those residuals left over from maybe a no-till system might adversely affect next year's crop. It seems like it might be a little bit different with tar spot.
Mm-hmm. Yes.
Okay.
And it's basically overwintering as those, within each of those black structures, there's 2 fruiting types that are produced. There's a an asexual spore and then a sexual spore.
Okay.
We're not 100% sure, but it looks like the sexual spores are more important in terms of epidemiology and plant infection. It's those bodies that we think are overwintering and then releasing spores in the spring.
Oh, interesting. And then Eric Anderson, our fellow field crops educator down in Southwest Michigan, has a comment here. Western bean cutworm traps in Southwest Michigan were up significantly last week. So just hitting that VT down there. So might be a good time to start scouting for those if you're more concentrated in the southern part of the state, but definitely Southwest. Thanks for that update, Eric. I appreciate that. I don't see any other questions, so I would just want to take this time to thank Marty, Jeff, and Phil, and the rest of our hosts for attending today's virtual breakfast. Again, you can catch us next week. We're going to be hosting Dr. Chris DeFonso, so it's going to be all about bugs. Again, you can contact her if you've got any bug issues. I think she'd greatly appreciate that.
Yeah, if you guys can send me some questions, that will, determine what we talk about next week.
Yeah, excellent.
So, otherwise, you just have to hear what I want to talk about, which is maybe not what you want to talk about.
Which I'm sure will be very interesting nonetheless, Chris. But yeah, we've had a very interesting weather year. So if you've got some stuff you're observing entomology related out in your fields, please contact Chris. She'd greatly appreciate that. Again, thank you very much to all that attended, and thanks very much to our presenters and host. And we'll see you next week. Thank you.